Now, for the last part of light itself, if you remember, there was one portion where we talked about reflection. When the light hits a surface, you can either undergo reflection, which we covered, refraction, and last but not least is actually your absorption. Okay? So when light is actually being absorbed, that's why we actually see different colors of light as well. Now, for rainbows itself, normally our white light, all our day-to-day lights that we see, right? They're actually made of 7 different colors, which are basically the colors of the rainbow that we have down here. So what actually happens is, for example, in white light, if you notice, this is air and this is glass, correct? So when you actually travel from air to glass, first thing, refraction will occur in the first place. So we'll try to align this roughly like this. 1, 2, 3, 1, 2, 3. So you can see that your light rays, your white light will actually bend towards the normal. However, you will actually notice that at different points in time, at the refraction portion over here, you'll notice that your different colors of light, they all bend at different angles over here. So the question now is, which one is faster, which one is slower? So on top, it bends less, means I slow down less. Okay, and below over here, you bend more, you slow down more. So what does this mean? It means that violet light is actually the slowest in your glass prism, whereas red light, the fastest light that you see over here. So you can actually have your different colors being spread out. You see the rainbow over here, and you can actually get them to recombine back into your white light over here using 2 different prisms as well. So normally we see the rainbows right after raining, right? So what actually happens is in the air itself, you have all your water droplets. All of these are water droplets. So what happens when your white light travels like this? It hits a surface, it will basically go into your different colors of light so that you actually form your rainbow that you actually see. So you, instead of using a glass prism, it is actually the water droplets that actually allows us to see the colors of a rainbow itself. Okay, so this one is referring to the colors of light. Okay, it is different, not art. Okay, so art itself is slightly different. For the colors of light, you notice that white color light, okay, white light is actually equals to red light plus blue light plus green light. Okay, it's not red, blue, yellow, it's red, blue, green. Now, if you add red and blue together, you actually end up with magenta. So let me see if I can get a magenta color. So this is magenta. Okay, it's a purplish pink color. Same thing, we have your red, and now let's talk about green. Okay, so red plus green, red, blue plus green. Red plus green will actually give you the color yellow. So let's grab the yellow color. So this will actually give you yellow. On the other hand, your blue plus green itself, they actually give you what we call a cyan, which is basically your sky blue. So cyan itself. Okay, so basically if you notice, your secondary colors are basically your highlighter colors itself. So you can just imagine red plus blue, magenta, red plus green, yellow, red plus blue plus green, cyan. If you add red, blue, green, you end up with white colored light. So all the lights that we normally see. So just take note of this combination itself. This part is where you will need to memorize. Okay. So now, like I said, we will learn about the 3 different parts, and this one is referring to absorption. So for example, over here, now we have white light over here, correct? So white light is red, blue, and green. If you land on an apple, let's say this apple is a red color apple, right? What actually happens over here is you have a apple over here, and you have white light coming in. So this is red, blue, and green. So when we see the colors of light, we see a red apple, correct? Why do we see the red color apple? Is because red light will be reflected off the surface. So the question now is, what happened to my blue color and my green color light over here? They will actually be absorbed by my, okay, they will actually be absorbed by the apple itself. So when you go in with three different colors, only red color will be reflected outwards. So whatever color of light you see for any objects around you, whether it's your clothes, whether it's the computer screen and so on and so forth, basically the colors you do not see are the colors that are absorbed, whereas the colors that you see are the ones that are being reflected away. So for example, you can see, let's say if I have a black color object, okay, so this is a black box. So if this is a black color box, what light will be absorbed? Remember, we had blue, red, and green from white light, right? So what color of light do we see? There's no such thing as a black colored light. So what it means is, if we see a black colored object, no light is reflected, or all light is absorbed. So technically, black is not a color. Black is the absence of color. Okay, so technically when we say black color, it's actually wrong. That's why all your shadows that you see, they are all black, because they actually block out all the light. So when you don't have light, you see black. Okay, so do take note about this. So if you have tinted glass, like for example, it's, let's say you have piece of green color filter. So when you have white light coming in, remember, this is red, blue, hang on, and green, right? So when you pass through a green filter itself, what happens? Your blue color, your red color, it will actually be stuck over there. And only green light will be able to pass through, because this filter is green color. It absorbs your red and blue and only allows green to go through. So do take note about that. Okay, so you can play around with all the things around you and double check yourself, such as your own clothes, the pencil that you have, the pen that you have, and so on and so forth. So now we don't always have white light. So for example, right now you have yellow light and they want to ask you, what the color does a cyan object look like? Okay, first thing, yellow light is made out of red color and green color. There is no blue color at all. Now, normally cyan is this light blue color, correct? So normally cyan itself, it will actually, normally it will reflect your green color and it will reflect your blue color. So since it reflects blue and green, normally it absorbs red color. So you can see over here, so if you have yellow light, which is made of red and green, red light will be absorbed and green light will be reflected. So what color do you see? You will see this object as a green color object. Okay, so you will actually see it as green color. Next, you see this person who's wearing black color under yellow light. So yellow light here, you see that he's wearing black. So when you see that he's wearing black itself, remember red and green. So when you see the color black, it means he absorbed red and green. Okay, so now you move on to a shot with white light. So remember, white light is red, blue, green, right? So now you see the four person who's wearing yellow, blue, green, and red. So this is a yellow shirt. Normally, yellow shirt means you will absorb. Remember, this is red and green, right? So you will absorb blue. Then if you have a blue colored shirt, what does it absorb? Okay, so same thing. A a blue colored shirt, you will reflect blue color. So you will absorb red and green. Then you have a green shirt, which normally reflects green. You will absorb red and blue. And then you have, the last but not least, you have your red shirt. So he will reflect red and he will absorb blue and green. So who is our culprit that actually absorbs red and green? So you can see over here, answer is not the yellow shirt. It could be the blue shirt. Red and green, it doesn't reflect this, and this is not correct. So our culprit is the man who's wearing the blue shirt. Okay, so you will just arrest the man who's wearing blue color. All understand? With that, that's the end for our light chapter itself. So do take note of your 3 different parts. Your reflection, you need to know how to draw your mirror images. You need to know your laws of reflection itself. Your refraction, you need to know how to draw your ray model diagram. You also need to know how to draw when you're moving from water to air, air to water, and so on and so forth. And all the 2 formulas that you have on top, as well as your absorption, your different colors of light. First thing, your light will disperse because of refraction. But for individual components, what color do we actually see is based off absorption of light. So just remember this one. Objects and the color that you see, they are slightly different. The color that you see is the one that is being reflected off. The colors that you don't see are the one being absorbed. So you can refer to this one for reference. You absorb these colors, you reflect these colors, you absorb these colors. So this side is all your reflect, this part is all your absorb. Okay, so with that, we have come to an end for your light chapters.